So I thought it'd be really good to have a look at how to set up an echo sensor. This is really good for robotic projects and sensing the distance of things and basically a rangefinder. And I've got all the information for this particular video off of the Raspberry Pi Spy blog, which is great. And here's a quick setup of how you wire it. This will be in the description field in an image you can download. So you're going to need the ultrasonic sensor and a couple of resistors, a 330 ohm and a 470 ohm resistor. We'll be running some Python code to get this working. I'm using the Adafruit Web IDE programming tool, which will allow me to get this code running. Click on the link below for a fantastic tutorial on how to set this up and get it all functioning, or alternatively my video on how to start programming with Python. So let's just log into our Raspberry Pi's Web IDE from Adafruit. Hopefully you've watched the video and you understand what's going on here. Click on this link, it will take you to a blog called Raspberry Pi Spy, which is run by a guy called Matt, who has loads of fantastic articles in there. So we're going to grab a copy of the source code and we're going to paste it into our Web IDE, save it as a file and then run the code. What the code does is it activates the ultrasonic sensor to transmit a sound wave, and then it waits for that reply. It then calculates the time between the transmit and the receive, and then it does a calculation based on the speed of sound, and this will actually derive the distance. So once we've saved our code and run it, we should see on the screen there successfully that it's got an actual distance. So that's great, we got one reading out of our sensor, and if everything's been wired up correctly it should have looked exactly how we had there. That second link is going to send you to the second code written by Matt, which is a slight alteration, and it will put it into a while loop and we'll get a continuous reading from the ultrasonic sensor. So as before, copy the source code, create a new file, paste it in there, and we'll see it getting a constant reading from the sensor. So here's the same code running again, but just with a real world example of what I'm actually doing. You can see here that the first reading is about 1 centimetre. I moved the block back and it's about 9 centimetres. And then I'll move the block away and run it again and it's about 5 metres, which is the back of my room. So the sensor's fantastic for really big flat surfaces like doors and walls and that type of thing. So if you're thinking about attaching one of these to a motorised robot, this would be perfect for that because it would be able to detect that distance. However, for soft furnishings and things that don't have very defined edges, it's going to be a bit difficult because the transmit could bounce off at any angle and you could get a very weird and strange reading. So I got most of the information from this video from the Raspberry Pi Spy blog. Please go onto there. I've got hold of one of the Berry Clip add-on boards that Matt's created that we're going to look at and hopefully in a future video. If you do some great stuff with an ultrasonic sensor, please do some video replies and put comments in the comments field. So if you want to get updates from me for new videos, follow me on Facebook or Twitter or subscribe to YouTube and all the rest of that old standard twaddle.